Okay, good evening, everyone. I'm proposing Agenova, a standard operating boundary for AI agent work. Our goal is simple. Every agent job should have a clear purpose, bounded authority, and evidence from start to finish. Let us begin with a normal agent task. Imagine we have an engineer agent or coding agent. You can task it to fix a payment timeout issue, run the test, and open a pull request. The agent may already know how to write code, how to perform all this action, but to complete the task, it need to call, it need to use model, it need to interact with the real world. This is where the operational risk begins. The agent code does not answer 4 important questions. Why is a worker running? What the agent can access? For how long? How do we keep credentials outside of the sandbox? And after the work is finished, what evidence remains? So today, many teams solve these problems in different ways. They build gateway, model gateway. They design access control for each application. But this create duplication and repeated work, and it also creates inconsistency. Agenova aims to provide one reusable contract which enforce this governance. Agenova is not Kubernetes for agents. It is not another sandbox product. We already have a lot of sandbox products such as Kubernetes Agent Sandbox, E2P, Daytona. They isolate the agent runtime. They manage the life cycle. Agenova runs on top of these sandboxes. It governs the assignment, records why the work exists, who requested it, what temporary authority it is allowed to receive, and which backend runs the actual work, and also record what happened during the run. So this design makes the Agenova backend neutral. During these 3 months MVP, we will build it on top of Kubernetes Agent Sandbox, simply because Kubernetes Agent Sandbox have a similar thematic design or control as our design. So it's easier for us to quickly deliver MVP on top of that platform. But we will still keep our platform backend neutral, meaning you can run it on any backend platform implementing our contract. Right. So this slide shows our core data model. First, agent code contains the reasoning and to selection logic. So agent code essentially is a program you write in LangGraph, OpenAI Agent SDK, or other tools. We will package the agent code as a image or artifact, and then an agent template as a YAML file describes the reusable role, such as an engineer, a data analyst, or a reviewer, and then a claim request, which is the specific task you want that role to run. Agenova will resolve that request into a sandbox claim. And one claim represents that governed worker run. 2 and model calls are recorded as fact under that claim. Here is an example of the agent template. So the template references the runnable image, such as a Docker image. It also defines the safe defaults and capability ceiling. For example, this engineer role, it uses this coding agent image. It can only use the models compatible to this model profile. Its max to permission is listed here, and only for the repository for the resource listed here. So this defines the maximum capacity your agent can request. And then for each job, so each time you want to use the engineer agent I just defined, you need to tell it what to do, because an engineer agent can create a feature for backend system, can fix a bug for a database. It can do a lot of things. So each time you define a specific task. So you need to create a claim request template. Here you define which agent template you want to use, and specifically what task you want it to run. For example, in this example, it is to fix a bug in a payment API. And also for this specific task, what permission you want to request to finish this task. And also eventually there's a timeout. But this requested authority scope or the permission is not the granted authority. We combine the template ceiling defined in the agent template, the requested specific permission, and also the platform policy, which you need to specify when bootstrap the Agenova cluster. So essentially, the combination of these three layers defines the effective claim authority or the permission your agent can have. This example shows, for example, you have an engineer agent running in the non-production environment, but you are requesting production deploy. Essentially, this evaluation will tell you, okay, you don't have that permission. It will fail your task, and also this failure will also be recorded in the auditing system. Now we can follow the complete flow. A client submit a task and request access. Agenova resolves the authority, create the claim, and select a runtime backend. The backend starts the agent worker as a sandbox pod. The worker then uses its claim identity to request tools, models, potentially in future also memories, via our controlled interface. And this interface keeps the long-term provider secret outside of the agent sandbox. So the agent sandbox never sees this secret. We use policy and role-based access control to grant the worker access to different tools and models. And in the end, we will have all the logs, the evidence, we'll collect all the, the life cycle, authority, outcome, failure, all the information during this run. After your run is finished, so everything will be recycled. The permission, the authority will be gone after the run. So you don't need to worry about the next agent will inherit the same permission. Our golden demo vision for the final presentation, we are controlling the scope of this MVP pretty cautiously. We want to keep it tight so we can actually deliver something instead of trying to deliver everything. So what we are trying to deliver here is this end-to-end flow. So we submit a a task. It may be an engineer agent, it might maybe a DA agent. We haven't decided that, but we will submit a task. It will create a claim, get access to the requested and permitted tools and models, use those tools and models, and finish the task. And all the actions will be recorded and visualized on UI, internal UI system. So after the work finish, all its temporary authorities should be inactive, as I said. A later to call because of this will be rejected. So this will also all be demoed in the final presentation. This interface on the right explains the same run. This basically shows the timeline of the observability. Essentially, we want to show like different stage of the life cycle. So every detail should be recorded in the auditing system. So here, the MVP, as I said, I think I just repeated myself, but essentially it contains, it will deliver the agent template, the claim template, the integration with Kubernetes agent sandbox. We will design a lot of interface, also create some default adapter. For example, we have two gateway interface, model gateway interface, but for two gateway interface, we will out of the box create some adapters compatible with, for example, AWS Bedrock intelligent prompt intelligence. I think the name is that. It's like a model router. So essentially, it supports us to demo an end-to-end agent workflow on top of our runtime. But it has a lot of potential. In future, after the MVP, we can still, add memory interface, which support memory management. We can add DAG. So essentially, each agent not only perform as a sole worker, they can interact, they can be orchestrated, but that will be after MVP. So for our team, we have a pretty diverse team. We have 10 people, spanning from infrastructure or DevOps to full stack to data, business and analysis, and AI. But we all share the same interest in AI infrastructure. That's what brings us all to this project. But each individual is joined to a specific part of this infrastructure. For example, Neil, Sonia, Frank, and Richard, they are more into the They are more into the, for example, the core runtime and governance. And maybe Sonia and Tom, who's from more full stack background, they are more into the gateways. So each individual have a kind of specific interest. But we will create tickets under each category, and each individual will pick the ticket that interests them. But together we will deliver this project end to end, including what I just said, the core runtime, the demo. The demo will include a demo agent, so we'll also create the agent on top of it. We also do some attack and chaos testing, so to make sure our system actually provides the bounded authority and protect the malicious request. We will also have interface. We will use CLI to submit all the Agenova requests. We will have a UI to visualize the workflow, visualize the auditing logs. Special shout out, we have Clarence, who is our BA, so he will work with me more on the scoping, the design. Potentially, we later down the track, we might also try to commercialize it and find potential customers. Yeah, we will essentially this 3 months today is a proposal, and next month we will have another showcase meeting, and finally we have the final presentation. But in next meeting, we will try to build the end-to-end path, but without really the UI maybe a demo agent, but we will try to have the end-to-end workflow, the control all in place. But in the final presentation, we will, as I said, have the demo agent, also have kiosk testing, we also have UI, all the pretty stuff. But yeah, that is our project at Agenova. Thank you, everyone.